friends, welcome to the channel of Digital to Real. Today we are going to discuss about the if generate statement in Verilog. In the same video you will be able to see the generate case statement also, and in the last video we have seen the generate for loop statement. If you require the video, see in the link in the description box. So, we use the generate if block in Verilog to conditionally include blocks of Verilog code in our design. Suppose I want to execute and synthesize a certain piece of code meant for a certain purpose, and the same piece of code I do not want to include when that particular condition is not met. So for that purpose we will have this generate if statement. We can use the generate if statement when we have code that we want to use under certain condition, as I said. Now example, when we want to include a function which is required in design for testing. So a particular test function is required when I want to see or test certain piece of code. I will include it inside the generate if statement. Another thing is that generate if statement will make sure that we will use this function with debug builds only, not with production build. Production build means the final synthesizable code that will go into the netlist, which will go into the FPGA. And here I want to have the generate if statement in order to include the function which is meant for debug builds, only the debugging purpose. Now we will see what debug build means. In order to do FPGA debug, in-circuit capabilities are added in Verilog code to track down definition errors, system integration problem, and system timing errors. So this is a piece of code which enables the Verilog code which is going into the FPGA to detect or track the errors, which are as follows: definition errors, system integration problems, and timing errors. So that is meant by debug build. Now production build means the Verilog code which is synthesizable go for the production. So final production in order to generate the netlist, then followed by the bit stream which will go into the FPGA. So build stage of synthesizer transforms the high level code to low level code. Synthesizer, what it does? It turns the synthesizable high level code to low level code. Low level code usually consists of gate primitives, design blocks from the cell libraries, IP codes. Okay, so that means by the production build. Now syntax for Verilog generate if statement. So generate statement is there, it is the keyword, then we will have the if. Generate if condition 1. If this condition is true, then begin end, code to execute. Else if the condition 1 is not met, we will look for condition 2. Then we will execute the code between begin end. Else we will execute the code final, this one, begin end. And finally we will have the end generate for the keyword generate. This looks similar to the Verilog if statement, but there is a difference. We will see the difference. What is the difference between the generate if block and the only if block which is used in Verilog? When we write a generate if statement, we are actually telling the Verilog compiler to create an instance of the code block based on condition. So as you know, generate is used in the synthesizable code of Verilog. So when we use the generate if statement, it tells the compiler, this particular statement itself tells the compiler that if a particular condition is met, then whatever is there in the begin end statement, let it go to the compiler. Else Other conditions won't go to the compiler for compiling and afterwards for execution. Only one branch is compiled by the Verilog compiler. Other branches are excluded. This is for generate if statement. When I use Verilog if statement, the entire if statement will get compiled and each branch will get executed. So I will show you an example how to use generate if statement. We will write a test function which outputs the value of 4-bit counter. And during the debug build, we keep this test function active. And when we build production build, what we will do? We will tie the counter outputs to ground. We will use a parameter to determine when we should build a debug version. Okay, this is in the example. Now let's see the Verilog snippet for that particular example. Use parameter to control our build comes under comments, then parameter debug underscore build is equal to 0 semicolon. Then conditionally generate a counter, that is also commented. Okay, generate if debug build is 1, begin quote for the counter, always at the rate of pausage of the clock, comma, pausage of the reset, begin. If reset is there, count is equal to 4 tick B0 semicolon, begin end. Else begin and count, that is equal to non-blocking assignment count plus 1 semicolon. Okay, generate if debug build is there, then this always block, always at the rate of clock, at the rate of pausage of the reset, begin if statement, counter 4 tick B0 semicolon, else count is equal to count plus 1. Else begin, initial begin, count is equal to 4 tick B0 semicolon, non-blocking assignment, and this end for this is begin. This end is for that particular begin. This piece of code will be included when the debug build is not there. Okay, and it is 0. So when we set the debug build variable to 1, we implement the counter circuit, else the counter variable is 0. Now we will see the case generate in Verilog. We use case generate statement in Verilog to conditionally include blocks of Verilog code in our design. It serves the same purpose like the generate if statement only. It does the same work as the if statement, generate if statement only. For example, we could design a test function which we want to include in debug builds. So here is the code snippet. Generate case variable. Okay, this is the syntax. If the variable for particular condition variable value is 1, then begin and this particular piece of code will be executed. If the variable value is value 2, this piece of code will be executed. If the variable value doesn't match 1 and 2, then default begin and statement, this piece of code will be executed. For this case statement, there is a end case value. There is the end generate for the generate keyword. The difference between Verilog case statement and generate case statement is provided below. When we write a generate case statement, we are actually telling compiler to create an instance of the code block based on a condition. When we write a generate case statement, what we are doing is that we are telling the compiler, if the variable value is value 1, then this particular piece of code you execute. If it is value 2, the other piece please execute. If it is not value 1 or 2, then the default piece of code you execute. This means that only one branch of case statement is compiled and executed. So Verilog generate case example I will show. We will write a test function. Okay, similarly like generate if, which outputs value of 4-bit counter when debug build is 1. Okay, and when production version of the code is used, we tie the counter outputs to the ground instead. So inside the comment, use a parameter to control our build. Parameter debug build is equal to 0 semicolon. Conditionally generate a counter. Generate case debug build if it is 1 begin. Quote for the counter. Always at the rate of pausage of the clock, comma, pausage of the reset inside the begin and if reset begin count is equal to 40 h0 semicolon, else begin and count is equal to count plus 1 semicolon, begin and end. Okay. For this begin, this end. For this begin, this end. And for this begin, this end. Okay. And this end is for this begin. Now here is the default. In the default value, the begin and statement, initial begin count is equal to 40 h0 semicolon. And here is the end for this begin. So this is the non-blocking assignment. And for the case statement, I have the end case. And for the generate statement, I have the end generate keyword. If you like the video for generate if block and generate case block, please share with your friends. Please subscribe the channel and have a very nice day. Bye bye.